Hello, thank you for joining in. I have been using R for more than 6 years now, but till now I have never created an R package. I never had a proper use case to build a package. But recently I found one topic which prompted me to write a package. I thought this would be a good use case to start writing my first R package. So I thought of sharing it with you all and the process of making it. Let's first understand why did I create this package? What was the motivation behind it? I like answering questions on Stack Overflow. On Stack Overflow, ideally, it is expected that the data is provided in a reproducible format, preferably using debug. There is a complete Q&A dedicated to it. You can see it here. This post actually explains how you can ask questions in a reproducible format and share data easily. Unfortunately, not many people choose to read and follow it. So, Stack Overflow supports a table-like structure which makes it look good, but it is still not reproducible. So if you share data in a particular format, it looks good on the UI, but it's not easy for someone else who is trying to help you to copy and use that data. Let me give you a couple of quick examples. You can see this post. If you look at this table looks good, but nobody can copy it and use it in R to provide an answer. This is another post where this table looks good on the UI, but it's not easy to copy it and reuse it. Since this is a frequently occurring situation and I deal with this situation many times, so I thought let's make a package here which is easier to copy, and if a user decides to provide data in this format, then I can copy it directly into a function. So if somebody provides data in this format, how do I bring it into a usable format in R? What I usually do is I click on edit. It provides data in this structure. You copy this, go to RStudio, use read.table, specifying this is a text in single quotes or double quotes. Remove this additional line which is not needed. Include header equal to true, and the separator here is pipe symbol. And I guess we would need strip.white equal to true. Okay, if I do this, I get a data frame. However, you'll notice that because of these pipe symbols here at the beginning and at the end, we have two additional columns called x and x1. So now we need to delete those two columns. And after we do that, we now have data in a proper data frame, and I guess this is the same data frame as shown in the question here, right? So you can see it takes so much of effort to just getting started. Now we have to put the same process in a function. Instead of manually deleting x and x1 columns like this, I'll use colsums and delete the columns which has all NA values in it. In very rare instances, there are going to be cases where these NA columns are actually present in the data, and most of the times it would be added because of these pipe operators. So I'll just add a note in the README that this function would drop all the NA columns. So let me show you the function which I have already prepared. This is my package repository, and if you go in the R folder, you'll see this is the function that I have. It's a simple two-line function where utils read.table is used to read the data and colsums is used to drop the NA columns. To generate the documentation, that is the help pages, we can use Roxygen skeleton. In this skeleton we put everything with a hash and apostrophe to identify it as part of the documentation. The param tags is used to explain the parameters of the function. The return parameter is used to define what is the return type from the function. And at examples, we'll show few examples how we can use this function. So I have this package loaded, so let's quickly look at the documentation and see how this part reflects in actual documentation. You can compare now this description, read data from Stack Overflow easily. The param tags are here, arguments. Right. Return is a data frame which comes under value, and this is the example which we have included here. Okay, so anybody can copy and run this example. You can see it returns a data frame directly. So in this case, for this case, if I had to use the package here, how I would have done that? Go to the question, copy the pipe delimited text, use readSOdata. In the codes, you pass in this, remove this line which is not needed, and if you run this, it should give you the data frame directly. So this is a very simple function. It does not do anything fancy, but yes, it saves me a lot of time, effort and energy in doing the same process again and again multiple times. I think even if I use this only once every day, I think still it's worth an effort to put this in a package. For this package, I've also added a simple unit test, the output and if the function behaves as expected. I have uploaded the code on GitHub if in case anybody is interested. If anybody is interested to have a look at the code, they can. I'll add the link to the GitHub repository in the description as well. As you can see, this function is nothing complex, but it definitely helps me. You can look for some similar use case to build up your first package as well. When you're starting, you don't have to build something which is going to be useful for thousands of users. If you can build something which is useful to only you, even that is enough. The important part here is to learn how to build an R package. There are a lot of resources available which you can use to build an R package. This package only consists of one function for now. So we don't really need a package as such. I could have just created an R script and source it into my session every time I want to use it. However, I anyway wanted to create a package for a long time, and now since I had this use case, I thought why not. I hope the video provided some useful information to you and you learned something new. I have added links to the resources discussed in the description. As usual, let me know in the comment section if you have any feedback or suggestions. Thank you for watching. See you soon.